This video will continue our discussion of limits and evaluating them in 3-space using something called the squeeze theorem that you have seen in Calc 1, hopefully. So this method in practice is, I think, concept-wise, very easy to understand. If I can bound this function that's in my argument here between two functions where I can actually find the limit at 0, 0, if that function is caught between two, then I know that that one is the same limit if they go to the same thing. Drawing a picture here, if I had so this is my function in question, and if I could bound some other two functions around it, right, that are squeezing in at this limit, let's say that's 0, 0, I know it doesn't make sense graphically, but I have this function that is always below and this function that's always above, and then they squeeze into a point there, then I know the limit of my middle function is that point. Concept-wise, kind of easy to understand. Setting it up is a different story. So let's give this a shot. All right, so let's take our 5x squared y, and I'm going to find a way to bound it, and this is going to feel like I'm just like making things up as I go. It kind of feels that way, and you're going to use this method to come up with interesting techniques to get there, to come up with stuff like this. I know I'm kind of talking very vaguely right now, but I'll show you what I mean. So this is what feels out of nowhere. I'm going to take the absolute value of this thing. The reason is I noticed that almost everything here doesn't need an absolute value. So I actually could just write down everything, like that's positive always, and then the denominator is positive always, and the only thing that needs to keep the absolute value is that y. Now, why did I do that? Well, okay, notice a few things. Notice that 5x squared over x squared is equal to 5. All right, so what that tells me, that if I take 5x squared and I add something to my denominator, y squared, that's a positive number because I squared it, that made my denominator bigger. So I know that this thing is no longer equal to 5. It may be if y is 0, but since I made the denominator bigger, it's got to be less than 5. Now, why would I do that? Okay, well, if x squared and y squared are positive, and all that's going to be spit out a positive number, I also know that this thing is bigger than 0. Now is where it's going to all come together. I know since they're all positive, x and y, right, the squareds are going to be positive, I know that that thing is caught between. Now, notice what I wrote down was everything except for that y. What I'm going to do now is I'm going to multiply everything by that y. Well, 0 just is 0. Then I'm going to get 5x squared times the absolute value of y over x squared plus y squared less than or equal to 5 times the absolute value of y. Okay, so here's the deal now. Notice that the limit as xy goes to 0, 0 of the left side, I get 0. The limit as xy goes to 0, 0 of 5 times the absolute value y goes to 0. And that thing is caught between. That tells me all three of these things imply that the limit as xy goes to 0, 0 of this whole function here, 5x squared times y over x squared plus y squared, is also equal to 0. Okay, but that doesn't answer what was in question here. The question was without the absolute value. Well, I know that thing that I wrote down is equal to the absolute value being on the outside, so I'm just going to work my way backwards. xy, as we approach 0, 0, this thing, which is the same thing as above, because everything doesn't need the absolute value, is also equal to 0. All right, from limits, and this is from Calc 1, because that's always going to be positive, then I know that the limit itself, I could just pull the absolute value all the way out. Since my values are going to be positive always, I can do this. or the only thing affecting it rather is that sign with the y. It's one thing, I guess. That what I said was kind of a bad explanation, but the reason being is the only thing added to this from step to step is this thing, which is only going to control my value by a positive or negative, right? Since it's the only thing affecting the sign, I'm not going to get y is negative and then it's going to cancel out with another negative. If y is negative, then the whole answer is that answer, but negative, but we want the absolute value, so it's positive. So this thing would still work out to be positive, or to be 0. But the only way that's going to be 0 is if the inside is equal to 0. And that's our last step. That was the problem. We know now that this limit is equal to 0. Like I said, this reasoning can be pretty difficult getting there. Typically, how I work with this is if I see a problem set up like this one and I see another one that looks like this one, I can do this one now. Otherwise, the squeeze limit, the squeeze theorem it's pretty difficult to work through. You have to find those relations of getting it bound between typically a 0 and something positive. Typically is how that goes. So this won't show up a whole lot, rest assured, but it is a very useful method.